Welcome to qnawire.
Over here, in order to know what is going to be the correct function, first of all, let's assume that we're in the plane. Let's say that we have our benzene ring over here. This is going to be in a plane. And what we have is that the carbon atom, first of all, one of the chlorines is going to be inside of the plane. And the other two chlorine atoms are going to be, let's put one looking at front and the other one looking at the back. Let me put this angle a little bit more clear just to make everything on plane. So what we know is that if the starting position for J equals 0 means that the chlorine atom is on the same position as the plane, what we're going to have is that the energy is at the maximum. So the potential as a function of J at potential equals to 0 needs to be equal to a maximum. And we cannot achieve that with the sine function because sine of 0 is going to be equal to 1. Sorry, sine of 0 is going to be equal to 0. So this needs to be a constant. Thus, the only function that we can employ is going to be cosine of something. Right? Remember, cosine of 0 is equal to 1, so this would be a constant value. In this case, we're going to have cosine square functions because we cannot have negative energies whenever we are rotating around. And now the next thing that we need to identify is what is going to happen when we rotate our molecule. I'm going to be looking at the chlorine atom as if I was going through this position over here. So I'll be looking at the carbon atom as if I were looking at this position. So essentially what we have is that the energy will be the same if I rotate the molecule 120 degrees. Remember that 120 degrees is equal to 2 pi divided by 3. Okay, so our function needs to satisfy this condition. In this case, from the options that we have, the only one that satisfies this is that Bj is going to be equal to a constant times cosine squared of 3j over 2. We put this j as minus. Okay, you can verify this by, for example, let's go ahead and rotate the function and evaluate it at j equals 0, at j equal 2 pi over 3, and at j equal to 4 pi over 3. Remember that this would be 0 degrees, 120 degrees, and 240 degrees, just to not get confused. Okay, so over here, the function would be equal to constant. On the second case, it would be constant times cosine squared of 3 halves of 2 pi over 3, which is cosine squared of pi, which is equal to a constant. Remember, cosine of pi is equal to minus 1. Cosine squared would be equal to 1. And for the last one, we're going to have the same thing. Constant times cosine squared of 3 halves of j, which is 4 pi over 3. 3 and 3 cancel out. 2 and 4 cancel out. We're going to end up with cosine of 2 pi, which is the same as cosine of 0. And this is equal to the constant itself. Remember that these factors are going to be equal to 1 directly. 1 and 1. So the function that we need to put to describe the potential energy then is going to be this one. And that would be all. Thank you very much and have a good one.